In this graph, they tell me that f of x is this line until it gets to the value c equals 5, at which point it jumps down here to this line to the right of 5. So the first thing it asks me is, what's the limit as x approaches c with a little positive sign here? You need to remember that positive means it's coming from the right side of the graph. Higher values of x, more positive values come from this side. Lower values of x, more negative values come from that side. So if it wants the limit as x approaches c from the positive, I trace from the positive side back towards this value x equals 5. It doesn't matter that it's actually at this point. What matters is where it's headed as I head towards that x equals 5. So this from the positive side points me towards a negative 4. If I trace from the negative side, I'm pointing towards this dot, a positive 4. Whenever you have different answers from the left side and the right side, it means the overall limit does not exist. So I would write D and E for this overall limit. They then ask me the question, is the function continuous at x equals 5? If the limit doesn't exist, then the function is not continuous at x equals 5. So this would be null. It's only continuous both if the limit exists and the limit equals f of x at that point. Number 4, 5, and 6, we're starting into our basic derivatives. So when we're asked in number 4 to find the derivative, I'm just using basic power rule. 2 comes down, 2 times 4 gives me 8t. T goes away, I get plus 9, and the 7 drops off because it's a constant. For number 5, here I have something times something. Each of them are functions of t. That's why I have to use my product rule. My product rule says that the derivative f prime of t equals first, t to the 8th, times derivative of second, cosine t, plus second, sine t, times derivative of first, 8t to the 7th. I probably want to clean this up a bit and just call it t to the 8th cosine t plus 8t to the 7th sine t. Number 6, make sure you're reading the instructions carefully. This says find the second derivative. I don't want to get any emails saying, hey, I messed up. I thought I was only supposed to find the first derivative. It specifically says in the instructions to -6, second derivative is what we want. So here I see that it's a quotient. I go to find f prime of x. When I go to find that derivative, I need to use my low d high minus high d low over low low. So low d high means I start with x minus 8, thing that started on bottom. D high, the derivative of the top, is 1. Minus high d low. X is what started on top, high. D low is the derivative of the bottom. Derivative of x minus 8 is 1. Over low low. So over what already was there, x minus 8. Quantity squared. If I resolve what's going on top, this 1 times x gives me a positive x. This x times 1 times a negative gives me a negative x. So those go away, and I'm just left with this negative 8 times 1, or negative 8 on top. On bottom, I have x minus 8 quantity squared. This is the first derivative, but again, the question asked me for second derivative. So I need to take it a step further and say f double prime of x. There's 2 ways to see this problem. Since really it's a constant on top, I don't need to use my quotient rule. I could bring this up as x minus 8 to the -2, do it as a chain rule, and I would get the same answer I'm about to get. That said, I am going to do it as a quotient rule just to show you that that method would work as well. So that tells me that I need to do low d high. Low is x minus 8 quantity squared. D high, since it's a constant, is 0. Minus high d low, in this case high, is negative 8. D low, the derivative of the bottom, is a chain rule. 2 comes out. It leaves me with x minus 8 inside. And I multiply by the derivative of the baby, which is 1. All of this is over low, low, or in other words, I square what was already there. So if it was x minus 8 squared, it becomes x minus 8 to the fourth power. Cleaning this up, this all goes away because it's times 0. This tells me a negative and a negative, which makes a positive. 8 times 2, which is 16. And then I have an x minus 8 here. I have 4 of them here. So what really ends up happening is the 16 is the only thing that's left on top. Again, from negative 8, which makes positive 8, times 2, which makes this positive 16. And then I cancel one of these x minus 8s with one of the ones on bottom. It leaves me with x minus 8 just to the third power on bottom.